Okay, I'm recording. Hello again. We're going to solve some problems with what I just talked about. So the first kinds of problems, and this is where we'll stop today. We're just going to do one type of problem, and then I will let you practice with those for your assignment. So the types of problems we're going to see will give you a function, and I'm staying away from the trig for now. So we'll see like primarily polynomial functions. And they would give you a closed interval, I don't know how well you can see that, and ask you to find the maximum and the minimum value, for example, on that closed interval. So if we were asked to find the extreme points on a closed interval, there are 4 steps that we would take. First, we are going to find the critical points. So we're going to basically take the derivative of this function and find all the places that the derivative is equal to 0. Those are our critical points. So that's our first step. Second step is we're going to evaluate the function at those critical points. Third step, we evaluate the function at each endpoint, so at -1 and 2 for this case. And then the fourth step, we look at all those values, and the smallest value would be our minimum, and the largest value would be our maximum. So I tend to make a little bit of a, like, I don't know if table is the word for it, but you'll see as I go through it. Okay, so we're going to go through that process. So for the function, again, I don't know how well you can see, sorry. This is just going to be a lot of awkward me moving things around. For the function, 3x to the 4th minus 4x cubed, we want to find the extreme points, the minimum and maximum, over the closed interval -1 to 2. Okay, so I'm going to go through those steps. They're in your PowerPoint. You should write them out in guided notes or however you take your notes. So step 1, I want to take the derivative of this function and find the critical points, the places where the derivative is 0 or undefined. So the derivative of the function, this is a nice and easy function. I can use the power rule, right? So the derivative is equal to, the derivative of 3x to the 4th power is, I'm going to take that power and multiply, so it's going to be 12x cubed. And then I say, the derivative minus the derivative of 4x cubed, which is going to be 12x squared. So that's our derivative. Now we want to find the places where that is 0. So we'll say 0 is equal to 12x cubed minus 12x squared. So when x is 0, that's definitely going to be a critical point. It's usually easiest to find the other value where we might have this whole function equal to 0 by factoring out. So I'm going to factor this out. I'm going to say 0 is equal to 12x squared times the value, let's see, what does that make this? X minus 1, right? And so if I look at this, I can see when x is equal to 0, I definitely get a 0. And when x is equal to 1, because here we would have 1 minus 1, which is 0. So 0 and 1 are my critical points for this function. So at this point, once you've gotten through this, we've really done the calculus. That's all there is to do it. So there's not any, I wouldn't say new calculus here. And then what we're going to do is evaluate this function at these points. But we're also going to evaluate it at the endpoints. So essentially, we want to evaluate the function at the point 0, 1, but also -1 and 2. So, you know, you can, you could say f of, just kind of write them all out. F of 0, well, let's go in order. Sorry, I'm all over the place. F of -1, I'm just taking them in order. You don't have to. F of 0, f of 1, and f of 2. So we're going to evaluate the function at these 4 points. So first I put a -1 in. Now I'm going to kind of cheat and look at the book just to do this quickly. So I go to the original function, so up here, and I'm going to put the value -1 in. And so when I do that, the function gives me a value of 7. Okay, so this is just plug and chug. I just put a -1 in up here. Then I put, my next value is 0. So if I put a 0 in here, I can see that I get 0, right? So that's what I get. Then I put a 1 in here. And so if I put a 1 in here, I'm going to get a -1. And then I go for 2. if I put a 2 in here, this time I have to look at the book. If I put a 2 in here, I end up with 16. Okay? So, again, I've gone through 3 of my steps. First, I took the derivative of the function and found where it was 0 to find my critical points. And that was like the hard thing. That's step 1. Step 2, I evaluated the function at the critical points, which is what I'm doing here. Step 3, I also evaluated it at the endpoints, which is what I did here. Now, finally, step 4. I look at where, can you see this whole thing? I'm like blocking my own work. There we go. I look at where the value is lowest, which is right here. And this would be my minimum. So the minimum for this function happens when x is equal to, to positive 1. And then I look for my highest point, which is actually right here. And so that is my maximum value. So for this function, my maximum value occurs when x is equal to 2. So of the 4 kind of important points that I had to evaluate, which was my 2 endpoints, and in this case there were 2 critical points, one gave me the minimum value, one gave me the maximum value. So a critical point, like for instance, a critical point was right here. We found that there's a critical point x equals 0. There was a little, if you graph this out on your calculator, your graphing calculator if you want, you see a little dip, but it's not an actual true minimum. It wasn't the lowest point. So it was a place where we had a tangent line equal to 0. So it was an important point to look at, but it actually did not turn out to be an extreme value. So that's the steps that we would take. I'm going to do it with one more problem just to give you a little bit more practice. Again, staying away from trigonometry, and hopefully you'll be ready to try it on your own. Okay, so the second function I have it written over here, but I'll recopy it. The second function is f of x is equal to 2x minus 3x to the 2/3 power. And we want to evaluate that function on the closed interval -1 to 3. Okay? So, our first step is to take the derivative of that function because we are after those critical points. So the derivative of the function is equal to 2, so the derivative of 2x is 2, minus, so 3x to the 2/3 power. When we take that derivative, that's 2/3 times 3 times x to the -1/3 power. And that cleans up a little bit, right? So it ends up being that the derivative is equal to 2 minus 2 times x to the -1/3 power. Now, you could, if you wanted to, make that into, clean up sorry, I'm losing my words. This term, so you could say this is 2 minus 2 over x to the 3rd, or the cube root of x, if you wanted to. And so I'm just cheating and looking at the values. So when is this 0 or undefined? It is 0 or undefined when this value is 2, right? So we're going to set it so this value is 2. So the critical points occur when x is equal to, I'm just cheating and looking. Zero and 1. Okay, so again, I'm just taking the derivative, and then I'm going to set it to 0, and then I'm going to solve for those values where it's either undefined, so undefined, like if I put a 0 here, that clearly makes it undefined, doesn't make it 0, makes it undefined, or the whole thing is set to 0. So 2 divided by 1 to the 1/3 power is 1, right? So 2 minus 2 is 0. So that's how 1 becomes a critical point, 0 becomes a critical point, again, because this becomes undefined. And then I go, sorry guys, and I am going to, yeah, I'm going to kind of cheat and just grab the numbers. But I'm going to go and evaluate this function at its critical points, 0 and 1, and at its endpoints, -1 and 3. So I'll just put them in order. That's what I tend to do. So f at -1, f at 0, let's see, f at 1, f at 3. So I'm going to plug those 4 values into the original. You always got to go back to the original. Don't do the derivative. Into the original equation. And so when I go, again, I'm cheating, sorry. F of -1 is -5 if you plug and chug. F of 0 is 0. I didn't need to look at that. F of 1 is -1. And F at 3 is approximately, I would put it in my calculator to get it in decimal form, -0.24. And so when we do this, we see that we have a minimum value here at f is -1, and a maximum value here at f is equal to 0. And you can always check yourself by graphing the function just to make sure that your values are correct. Okay, so we're going to stop there for now. So hopefully this makes sense. Again, take the derivative, find, I didn't write this down really well, this final step. Find out where this is 0. So 0 is equal, this is what I was solving for, 2 minus 2 over x to the third. And that's how you get these, excuse me, that's how we get those critical points. So take your derivative, set that derivative function to 0, solve for where it's equal to 0, those are your critical points, and evaluate your original function, not the derivative, at the critical points and at the 2 endpoints. Highest value is your maximum, lowest value is your minimum. Okay. See you next time.